Hello folks, well it's Amstrad 901 time again, and again we've got a genuine made in Japan one, so it's always nice to see. And that was the later mic which you got, which is like the Harvard mics when it's a Cybernet set, because these are a Cybernet set, so that's nice to see the right kind of mic. So something I've got to query with the customer is, do they have the power connector for this? Because this is the one that's been long obsolete. What we can do is to fit the round square type with an adapter plate and some hot glue as well. So we'll drill in an adapter plate and then support it with some hot glue on the inside, because this is, if I remember rightly, one of the two which is wider than the square round one. The other type you end up having to file out. So that's the narrower one on that scrap set. All interesting stuff, eh? Right, so the report that the bar graph display is not working, and that usually means that at some point or other the radio has been reverse polarity. Now I've got the mating type of lead. It isn't for sale, it's the one and only one we've got. So we'll run it off that. Connect that to our famous crocodile clips. "10 minutes before dinner, dinner being dinner time, as in 12 noon. Good. Connect it up to the test equipment. Instead of using their mic, we'll use our standard Cybernet mic. Right, power supply on, 13.8 volts selected, and it powers up. Bit of noise on the volume control, and key it up, and there's no bar graph, so there we go. Same firm as the Murphy CB27 yesterday. I'm sure this is a better set than that, in all honesty. 16th, 17th today. Okay, let's put picture in picture on, and we're on the 3 watt scale. See what happens. Nothing. That's not a good sign, is it? I hope this isn't one that's... Have I plugged it into the... I plugged it into the roof area instead of the test equipment. We'll be interfering with the bad buddies. Right, try again. That's better. 2.95 watts on channel 20. Channel 40. Milliwatts. The VCO is going to be out then. Channel 1. 2.9. Low power on channel 20. $220 milliwatts. transmit current on full power. .148. Deviation, for what it's worth on this test set, Wallow. This is 1.5. So that's going to have to be sorted. Test gear's been on about 15 minutes, so it's not going to be at full accuracy yet. But let's have a look at where we are. Are we still on low power? No, we're not. There's a dry joint somewhere. .27.79063 isn't good news. Needs to be above 100 for me to be able to send that back. I'd like it to be 125, of course, but they're not all going to go. And have we got the crystals? I keep buying crystals from various cheap suppliers and they never work. I don't say, well, you can send them back, because they work within the, you'd expect the tolerance, because we don't know what the loading thing is on these sets, do we? Oh, right. So, none, not applicable, vol dirty. We can hear the Roger Bleak working, channel 9 works, see if PA works. Let's get our speaker plugged into the PA socket. It's gone the wrong side of the aerial lead. Testing 1 2. Testing 1 2, testing 1 2. So it would work if the volume control was better. So that's okay. They work. The speaker works. Right, let's have a look at receive. So if we dial in the same wrong frequency, speak back to CB, and put into the signal range to 27.79063. I'll do. And plug the test gear into the speaker socket. Right, let's have a look. So we've put the SINAD meter on. And let's see what we've got. .75. Should be a bit better, but it's acceptable. .67 for 20 dB. Is 1.85. Squelch, genuine one, it should work okay. So it's a full squelch. Let's go to the attenuator. Want it to come in at 100 microvolts, 10, 20, oh, it's coming in at, get a reading, coming in at 30 microvolts. It's a bit slack. And for maximum sensitivity of the squelch, that was RF gain, probably turned the wrong one. Put the signal generator to standby, squelch to threshold, that's dirty as well. It's coming in at 0.3. Okay, unplug the mic and we'll get the screw missing there. Because it's got a screw there in the wrong place. Speaker needs rotating, it's not at the right point. So the bargraph display driver chip is down there, so that's what's causing the problem with the no display. It certainly had some work, hasn't it? That protection diode needs putting in the proper place, not bodged on the bottom of the board. What's happened there? Really don't know. Yeah. Right, we'll start by sorting that display chip out. Right, so I've had a look round for one of these display driver chips. We've got them new in stock. I think they're $5.99. I noticed somebody, I looked on eBay, and noticed somebody in Italy's got them for a few pence less. They've got them for £5.64, but plus a fortune in postage. So I think we've got 9 left. So get that in, it goes there. So get that unsoldered and put that in. Okay, I've done the bar graph driver, so that's now working. So what we're going to do is very quickly just see if it's going to go on frequency. So make a start, see whether it will do more than 3.6 watts. So my hard and fast rule is, if it does more than 3.6 watts, that's fine. If it doesn't, we're going to have to change the ballast resistor to 1, which is more hefty. These are 3 watt rated, but you can sometimes get approaching 4 watts out of the set. Obviously that gets hot, it's supposed to. Right, let's go into transmit. I'm going to do the VCO in a moment. We'll just see if we can do this first. Tell you what, we're not going to transmit, we'll go into frequency counter. We're there, we're near enough. Toggling 117. So when it's been on a bit, when the test set's been on a bit longer, it's going to be a bit higher. That's fine. So although it's at the end of its travel, it's 40 years old, and that's not going to be a problem for a good 10 years, I'm sure. So we'll just see if we can bring up the transmitter, or whether I've got to be soldering some more bits in. I'll try and keep the cost down. You know, that's the plan. I'm not like one of those garages that whistles through the teeth and think, woo! So, 3.1. Am I showing you the right meter? No, I'm not. 3.1. Yeah, that's it, 3.8. That's fine. So when it's cooled back down, I've no doubt that that's going to be even higher. Just check these coils are placed right. Yeah, Mr. Coil Stretcher's not... It's part of the alignment. I don't like the way it's done. But Maxon do it as well. In fact, now we've got that coil back how it should be, unstretched, we're down to 3.5 watts, so we will change the ballast resistor. Right, let's power it back up. So these are the same size, probably even smaller, but they're 6 watt. Doesn't mean the radio will do 6 watts, but it means that the it's not going to get stupidly hot. And if you can understand it, you know, if you've got a 3 watt resistor and you're trying to get 4 watts out of it, you know, it's going to be struggling. You know, we're over 4 watts now, so we can bring it down. So once again, we want to peak that one. And then drop this one. And there we are, dead on the 4 watts. So he's had the phantom coil stretcher, and once I put those right, it wasn't doing the power anymore. I had to take the front off to get to things, so it's a struggle to change channel. It's 4 watts on channel 40. It's 4.02 on channel 1. Expect the pen's on the floor. No, it's not. We'll take it back to channel 20. See what the current consumption is, 1.36. And see what low power is. 280 milliwatts, sorry. Alright, we'll do this VCO because it's clearly not right. I'll put negative to power supply negative. And see what we've got at the on and off switch, 13.8. So the far side of this capacitor is capacitor 9. I've got the sheet here. So we do this on channel 1 on these, and they want it to be 2 volts on channel 1 for transmit. Sorry, we start off on receive. They want 2 volts on receive, and we're going to adjust T1. Before I adjust that, I just want to put it into transmit, because it's going to affect. There's 2.7 on receive, and it's 2.4 on transmit. Right. So on receive, 2.0. So if you remember, we didn't have some channels on this. So now, transmit has come right at 196. So on channel 40, on transmit, um, 3.1, on receive 3.7. They say 4 to 4.5, but that's not quite as it turns out. Yep, that's now transmitting on both ends of it. Let's transmit. There's the receive. The receive was affecting transmit. They are interactive, and that's why it wasn't transmitting on whatever channel it wasn't transmitting. Was it 100 milliwatts on channel 1 or something? Pretty crummy. Go through the receiver. Start with the detector. 100 microvolts. And the detector is that one. Put a bit more volume on it. And let's show it on the inset picture. Wow! That's miles out. I bet that sounded awful. Right, let's get on with the front end. We'll look at the SINAD meter. Need less signal. Need to turn the squelch down too. To be honest, the front end's about where it should be. Biggest signal on for the IFs. A bit out there. See what we've got now. So for 12 dB, 0.2225, 0.221. $10 dB, it's going to be just less than 0.2. It is 22 that. And for 20 dB, it's 0.5. What a massive improvement. Let's see whether we've done anything with the squelch. Oh, it needs cleaning. So does the RF gain. Right, squelch to full, and this on there. Right, I want it to be 100 microvolts, so 3, 10, 30. It's too early, so we'll just drop that off. That's now too tight. That's it, 100 microvolts. So that's set up as long as it's right at the other end. So we'll see what it's like at the other end in a moment. And turn the signal generator back to standby, turn the squelch down on the radio, set the threshold, signal generator back on. It's coming in at 0.28. Excellent. Right, I'll start putting this back together and we'll set up the meter. Right, it's time to calibrate the meter on it. I've ended up changing the volume control. The switch cleaner wasn't getting anywhere, so it must be a damaged track. So I've managed to recover one off a scrap Mustang, so that's makes it a cheap part, doesn't it? Don't want to wait 6 weeks to import one or whatever. Anyway, so now we've got a nice smooth volume control. Right, so we want on the signal generator. I'll tell you what. Let's see where the frequency is for a final. 79116. Right. So we'll set the signal generator to exactly the same as we did before. So we're calibrating this to S9 of 100 microvolts, and as you can see, it's showing all the lights. So we just need to back that off. So the S meter adjustment is there. Just drop that so that it's not lighting the green, but making sure the green does light up with a bigger signal, which it does. On transmit, we want 4 to light. We're on low power. So I'll get ready to adjust that, which is there. There we go, we've got 4. When we go to low power, it should be 1, which it is. Again, it's a relative power meter, so that's subject to SWR, etc, etc. Now, where did I put that front? That's where I put it. We are, they're all in. Put the screws back. Always be careful not to over tighten these screws, you can see that there's some cracking of the plastic. They just need to be in there, don't need to be tight down at all. I'll just get the final screw in this bit, and then we'll do the deviation. So when we first started, the deviation measured 1.5 on the Marconi test set. So let's see what it reads now, a few hours later. Helps if I turn the radio back on. Now I'm going to have to use a trimming tool to switch it on, because I haven't got the knobs on it. I want to just give them a clean off. Wallow, it's still reading about 1.5. So we'll go over to the other test set. So I've got the quartz lock 282A on the bench behind me. Let's see what we've got. Change his glasses. Wow, it is only 1.5. Normally these are stupidly high, aren't they? Wow. Come back in 5 minutes. I'm not sure that machine's stable yet. Okay, so I've done that. I'm back on the other test set. Let's see what it says. Wow, it says about the same, so it is where it should be. You know, I don't think this has been touched much. Let's just turn that volume down. So it was 1.5. Now it's 2.2 to 2.5. So it's ballast resistor. Gone from 2.95 to 4 watts. Deviation's gone up. Sensitivity's increased. That's now correct. They've been cleaned. I did the tone as well. We've just got their mic to check. I'll just put my walkie-talkie on. Testing 1 2, testing 1 2 3 4 5, 1 2 3 4 5. That's with our mic. Try it with theirs. Testing 1 2 1 2, testing. Testing 1 2, testing 1 2, testing 1 2 3 1 2. 1 2 1 2. That doesn't work. It feels like it's trying, so it could just be a dirty switch. I don't know when it was last used, of course. Very pleased with the results of this set. It's exceptionally good. So I'll just turn it off so I can push the transmit button lots of times. Try it again. Testing 1 2. Let's fix that. At the end of the day, they're self-wiping contacts, aren't they? But I think we needed a bit of help with that one. Let's take the service or switch cleaner back to Mr. Chippy's bench before he notices. Testing 1 2. Right, 1 2 1 2 1 2. So go back to that volume level. We'll go back to our mic. Testing 1 2, testing 1 2. There we go. So we'll compare those at the end of the video. So I'm just going to recheck that we've got the S9 right, because it seems to have shifted in putting the set back together. You know what, the tone is bent. I'll look into that. Right, I took the front off yet again. I'll know how to do this soon. And that's now not bent. I think I've been 4 hours on this, you know. Right. Go back to our mic. That's bent slightly as well, the volume control. Right, we were just doing the final calibration of the final calibration. So RF gain to full. All this messing about seems to have knocked it. There's S9. Right. Our power lead is loose. Can't be many people have got these. I inquire as to the customer whether they want us to swap this. So to that end, I'm not going to put the screws in the case till they've answered my query, which of course is now going to be tomorrow, because I think we're about 7 o'clock in the evening and it's getting darker. And where's my little precision screwdriver to just tighten this up? Just need to get that in there. Tighten these up. That's better. Quick power check, it's just doing over 4 watts. Good, we're all done. I'll put the lids on loosely. I wanted to change this, I wanted to slacken this speaker off because it was not at the right angle. That's where it really needs to be. So I did rather a nice Amstrad the other day, but this actually works better. As in, we've got better receive sensitivity. It's this old thing, you know, you can have 1,000 sets, they're all going to be different. And this is the 1 in 1,000. That diode, when I look at the board, because it's been reverse polarity, it's burnt the print away. So they've actually done the best job possible, really. If I take that out and reinstate the hole, there's no track there. So I think what they've done there is as good as we're going to get. But I will clean the board up with isopropyl before sending it back. But let's just see what they say about whether they've got a power connector. So there we go. We'll just get the own speaker on it. I think it's coming up to 7:15. We'd like to get the on the air test done. Turn the test gear off. Well, now, Roger.
3 watts linear.
3 watts into a linear. That was a giveaway. 19 a Roger. We'll get it on Mr. Mega Chippy channel ready. Yes, I think it's time the authorities had a bit of a sweep round Nottingham. Right, thank you for watching the Amstrad CB901, genuinely made in Japan, which turned out to be a cracking set.